Hello everybody. Here's a quick lesson on algebra tiles. This will replace problem 4-70 in our CC2 textbook. Very quickly, we're going to start talking about the following tiles. This one, and that one. If you're doing this at home from the link that was given in the lesson, um, pull out those three tiles so we have something to talk about. Now, these tiles are special. They're called non-commensurable algebra tiles because they don't measure up. Well, they kind of measure up on some of the sides. For example, these two tiles can go together. If I double click this one, I can put it on that side. If I bring this one out, it'll fit on that side. And this one will fit on that side. They fit perfectly. Oh, and look at this. This one fits right there nicely in that corner. In fact, you can put unit tiles, these tiles, on the ends of those sticks, no problem. Or maybe you can line them up down here and have something that is this long. Now, these tiles don't measure up. What I mean by that is if you were to take these same unit tiles and put them along the long edge, you can see that it doesn't quite make it to the top, right? It would hang over if you put a fourth one on there. So it doesn't measure up. That's because we don't know the length of this side. If I were to take a long side, I'm going to throw these out for a second, and put it against the long side, that's no problem. But if I take this same tile and try and line up the long side with a short side to use this tile as a measuring device, there we go. I run into the same problem I did over here where they didn't measure up. See how there's a missing piece right there? So here's the rule. You may put a long side against a long side because they have the same length. You may put a short side against a short side because they have the same width. You may put short side against short side, unit tiles against unit tiles, and you may put X tiles, as long as they're facing in the same direction, together. In fact, you could put these tiles end to end because they have a one end also. If you have more X squared tiles, more of these tiles, you can put them together as so. Now, that brings us to the names, which I've kind of been slipping on there in my speech if you heard some of that, if you were listening. This tile is called a unit tile. It's called a unit tile because it is a one. Let me get my marker here. It is a 1 by 1 square. And if you take the area of any rectangle as length times width or base times height, the area of this would be 1 times 1, which equals 1. So this is called a one tile, or better, it's also called a unit tile. So if you hear me referring to something as a unit tile, I'm talking about the dark blue tile here. The next tile that we would consider is this tile right here. This tile has one of the characteristics of the dark blue tile. This tile has a width of 1 here, but the length is unknown. We don't know what that is. So for our purposes, we're going to refer to that unknown length as x. If I take the area, length times width, of this rectangle, I get 1 times x, which equals x. So this will be known as an x tile. And the last tile that we need to know about is this big guy right here. Well, we know from before that this tile lines up perfectly with the side that we now know is called x. This is an x by x tile. The area would be x multiplied by x, which means we need to use some exponents to get the answer to that one. That's x to the second power. This is called an x squared tile. So from now on, I will refer to those big ones as x squared tiles. Now, these type of tiles, when you put them together, I would call, like, if I put two of these together, this would be referred to as 2x squared, because there's an x squared plus another x squared. And likewise, if I put an x tile and another x tile and another x tile and a 1, I might call these, I shouldn't put that 1 along that long side, should I? No, I'll just put it separate. I would call this little group of tiles right here 3x plus 1 square units. So that's how we're going to use these tiles in the very near future here. Ooh, not that. Okay, so on one of your activities here, let me get rid of that, bring this up. I'm going to be jumping over here to number 71. We need to explain what this pile of tiles is called. When a collection of algebra tiles is described with mathematical symbols, it's called an algebraic expression. Using the pile of tiles pictured at right, work with your team to do the following. Use mathematical symbols, numbers, variables, and operations to record the area of this collection of tiles. Write 3 different expressions that represent the area of this tile collection. Write these here. So to do that, I need first to figure out how can I type x squared, because we don't know how to do that yet. So let me give you a quick picture here. Let's see. I'm going to bring up this photo. If you want to type x squared, you're going to type an x, and then you're going to type, whoop, that should say x to the second power. That's an error right there. There should be a 2 right here. Sorry about that. So you're going to type x squared. You need to type x with a caret. That little symbol there is called a caret. By typing x, holding down the shift key, and type 6, and then type 2. So if you look right here, there's this little symbol that looks kind of like that. That raises the 2 up like an exponent. So when you type x, shift 6, and 2, you will get x to the second power. So let's use that now to go ahead and close that. Actually do this problem. So in this problem, if I were typing this out right now, I see 1x squared, which I'll type as x, hold down the shift key, 6 squared. See how it raised the 2 up? Plus, I see 2 x's, plus, I see 5 unit tiles, plus, I see 2 more unit tiles, plus an x, plus an x, plus 2 x's, plus a unit tile. So what I was doing there is I was saying, I'm going to go ahead and circle these in the order I did that. I have an x squared, I have 2 x's, 5 units, 2 more units, an x, another 2 x's, and a unit. This description describes this pile of tiles, but that's an awful lot to type. So what we're going to do is we're going to try and type that a little bit shorter. So maybe a second way to type this would be, I could say something like x squared, move over, plus 2x plus 5 plus 3, the other 3 dark blue unit tiles, plus 4 x's. So in that problem, I took this part, I took this part, I took these 5, I took these 3 right here, and then I took the 4 x's in my explanation. But that still doesn't seem to be the shortest way. Do you know the shortest way? So let's go ahead and type in x squared. Remember x, then shift 6, and then the 2. Plus, I'm going to count up all those long blue tiles. 1, 2, 3, 4 x's. Plus, all of those unit tiles, the dark unit tiles. There's 5 on the right, 6, 7, 8, plus 8. X squared plus, oh, wait a second, I got the 4x wrong. There are 1, 2, 3, 4, 5, 6 x's. 6x, there we go. X squared plus 6x plus 8 is the easiest way to write all of these tiles. Now, we can't add these together because these are unlike terms. You can only add together the things that are alike. So when I go ahead and do the addition, I have an x squared tile. I have 1, 2, 3, 4, 5, 6 x tiles. And then I have my 5, 6, 7, 8 unit tiles total. Check, check, check. But they're all separate because they're unlike terms. Anyway, your job now is to go finish the rest of our Desmos activity working from pages 8 through 14. Thank you for your time. On your mark and say go.